Hello, everyone. Now we are look at chapter 3, section 3. Look at energy. What happens to energy in an ecosystem? The concept is, as energy flows through ecosystems in food chains and webs, the amount of chemical energy available to organisms at each successive level decreases. So the key word is decreases. And then the food chain is the movement of energy and nutrients from one trophic level to the next, such as photosynthesis, go to feeding, and then go to decomposition. And then food web are the network of interconnected food chains. So this diagram showed you a food chain, start with solar energy through photosynthesis. You get to the herbivore, and then herbivore get to carnivore, and then you get to top carnivore, the tertiary, and then along the way, decomposers and detritus feeders will eat the leftover and then recycle the materials back for photosynthesis. This diagram shows you a food web. You can see the interconnected food chains. So one important thing about energy is usable energy decreases with each link in a food chain or web. So one concept used in this process is called biomass. So how do we measure biomass? Biomass is the dry weight of all organic matter of a given trophic level in a food chain or food web. So the more dry weight you have at a certain trophic level, the more energy it has. So this biomass decreases at each higher trophic level due to heat loss. Guys, remember the second law of thermodynamics. So if you look at energy from a lower trophic level to higher level, you would see a pyramid. So this one is called a pyramid of energy flow. So 90% of energy lost with each transfer. This number 90% you need to remember. So less chemical energy for higher trophic levels. So if you have a level at the beginning, let's say 10,000 kilocalorie from producer. And then when you go to herbivore consumer, then you only have 1,000 left. And then go to a secondary consumer, and then 100. And then go to the top consumer, only 10 kilocalorie left. So every step you lose 90%. And then one way, so during the ecosystem, the most important part is photosynthesis, because other things cannot fix solar energy. So some ecosystems produce more plant matter, which means they do more photosynthesis than the other. So how do we measure that? There's two concepts. They are very important. The first one is called gross primary productivity, GPP. So this one is a rate at which an ecosystem's producers convert solar energy to chemical energy and biomass. So this one is measured as kilocalorie per square meter per year. So this is a rate. So the more plant you have or the more solar energy you have, the higher GPP you would have. That means the rate is higher than other places. Okay. And then another concept is called net primary productivity, NPP. So what is NPP? So NPP is also a rate at which an ecosystem's producers convert solar energy to chemical energy. Here's the important part, minus the rate at which producers use energy for aerobic respiration. So ecosystems and life zones differ in their MPP. But MPP is important. Why do we say that? So MPP decides consumers, including you and I, how we would be able to survive. So give you an example. So let's use your father as example. So your father is the producer of your family. So he has his pay rate. For example, let's say 1 hour per, so $100 per hour. Let's say that. Okay, but he also need money to survive by himself. So this $100 per hour would be his gross payment. But if you minus the money he used, let's see, he used $20 per hour. So minus this one. So the net payment for him would be $80 per hour. So this net payment is for you and your other siblings to survive. So think about the gross payment and then the net payment after your debt's use. Okay, so the same thing. So the leftover after the plant use the energy they produced, MPP decide how many consumers an ecosystem can survive. So this concept is critical. So now we are looking at different areas to compare. So you don't want to destroy the areas has higher MPP because they are the one bring income to you and me and then all the other consumers. Okay, so look at the green part is terrestrial ecosystems. The blue part are aquatic. So the part we don't think they are that great is swamps and marshes. They produce tremendous amount of MPP, support life, eventually support us. Also tropical rainforest and then temperate forest. But however, right now, we do not have much respect to those areas. Those areas have been so damaged by human activity. So when you look at aquatic ecosystems, the highest MPP is estuaries. So what are estuaries? Estuaries are the area where river and ocean meet, that area. So that area we are not also doing well. Most of the land pollution get into estuary. Okay. So guys, along this one thing I want you to pay attention is you look at the open ocean. So open ocean actually has low MPP. Do you see the bar at the bottom? However, open ocean is important. Why open ocean is important? So look at the unit of MPP. It's a kilocalorie per square meter per year. Ocean occupies 70% of the Earth's surface area. So although if you look at a square meter, open ocean do not produce much. But if you combine with its huge surface area, open ocean produce a lot of biomass for the ecosystem. Okay, I hope you would remember the top 3 MPP in terrestrial ecosystem, in aquatic ecosystem, and also know why open ocean is important. Okay, so think about it. MPP is the energy and the biomass for all consumers. But do you know how much human beings use MPP? Although we are only about 1% of the total consumers on this earth. So some ecologists estimate that humans now use, waste, and destroy about 38% of the Earth's total potential MPP, while human population makes up less than 1% of the total biomass of all the Earth's consumers. That's not a good news. All of us, we should have a responsibility to correct this number. Okay. So now we're going to get into section 4, but this video will not finish all of them. So section 4, we are looking at matter. Instead of energy, we're looking at matter. So matter in the form of nutrients, cycles within and among ecosystems and the biosphere. The human activities are altering these chemical cycles. So one important thing you need to remember is when the sunlight comes in, there's energy, no matter for this earth. So what that meant is the earth has a lot of matter, but limited. So we have to reuse them, recycle them. Every part of the ecosystem can use them, okay? So nutrient cycle, we're going to look at hydrological cycle, carbon cycle, nitrogen cycle, phosphorus cycle, and a little bit of a sulfur cycle. And then the nutrients may remain in a reservoir. That means a storage area for a long period of time, like carbon in fossil fuels, stay there for a long time, okay? And then first we are going to look at water cycle. So water is an amazing substance. So hydrological cycle collects, purifies, yes, keeping this word purifies, and redistribute the vast yet finite amount of water on this earth. So the water cycle purifies water. So only about 0.024% of the water is immediately available to all living things. When we mention immediately available, this means they are fresh, liquid water in accessible surface and underground reservoirs. So the other part, majority of water, they are not immediately available, such as seawater. You can't drink seawater, right? So there's 3 major processes during water cycle. These are evaporation, precipitation, and transpiration. So transpiration may be new to some of you. Transpiration means evaporation from plants, especially the leaves, not from water surface, not from river, not from ocean. Transpiration is water evaporation from plants. So a number you needed to remember is over land, over the dry land, most water, so 90% that reaches the atmosphere comes from transpiration. So the water leaves the land, getting into the air, but how is it through plants? So if you cut down plants, that would impact the transpiration, impact the water evaporate from the land, okay? And then the water cycle, most of the precipitation falling on the terrestrial ecosystems becomes surface runoff into streams, lakes, and oceans. So how we human beings alter the hydrological cycle. So when you see how humans change the hydrological cycle, don't mention pollution. Only mention how we infect water, evaporation, precipitation, and transpiration. Okay, so number 1, we withdraw of large amounts of fresh water at rates faster than nature can replace it. So we make the water in underground less. Okay, and then clearing vegetation and making impervious surface area. When we clear vegetation, there's less transpiration. Also, there's less water be able to sink down into the ground. And then we also increase flooding because the wetland we destroyed, vegetation we destroyed. So there's nothing to hold water. Water just rush through to flood somewhere else. So this diagram shows you the water cycle processes. The red boxes are not good. So increased runoff, land covering with crops, buildings and pavement, over pumping of aquifers, increased runoff from cutting forests and filling wetlands, and etc. So the red part are human interaction. And then also water is an amazing molecules. So this part is a review. So cohesion, adhesion, and then this one expands as it freezes. They are universal solvent. This one is also filtered harmful UV light. So this one is why make water amazing is the hydrogen bonds between the oxygen and the hydrogen of another molecule. Okay, I'm going to stop here. Next time we're going to learn carbon cycle.